HIV has been with us a little over 20 years now, and enormous amounts of efforts have gone into trying to find a vaccine against HIV. The situation and our understanding is pretty straightforward because the virus replicates very quickly, but also changes its genetic material, the genes that encode its proteins, on a daily basis. The immune system has a problem on targeting the virus, such that on a daily basis the proteins encoded by the virus change. The immune system, to generate what we call a neutralizing immune response, takes weeks to generate. And so as far as the virus is concerned, it's a moving target. And the immune system really does need a static target, a protein that doesn't change, such that because HIV mutates its genetic material so frequently, so rapidly, the immune system is always several steps behind the virus. And when the immune system does generate an immune response against a virus protein, it kills that virus, but other viruses are selected and are able to replicate because there's no immune response feasible. So the challenges for HIV vaccines are very real and is very noticeable in the respect that we haven't been able to find one over 20 years. However, as we continue to study the virus and the immune system, we're looking for regions of the virus that change less, simply because the function of that protein cannot be changed, and therefore there are conserved regions within those proteins. Now, the virus is clever in the respect that those conserved regions are often hidden from the immune system, but many investigators throughout the world are trying to exploit as best we can what some of those weak points in the viral replication cycle might be. So targeting conserved regions of these HIV proteins may be a way forward. I think our ability to generate better immune responses and faster, so that is antibodies which can neutralize the virus, what we call T cells, white blood cells, able to kill infected cells, getting high enough levels of those types of cells to afford the killing of the infected cells, all very important. And even now people are looking at maybe not targeting necessarily HIV proteins, but proteins provided by the cells that the virus needs to replicate. If some of those proteins could be targeted safely by the immune system, we may prevent the virus from continuing its replication. So whereas perhaps a few years ago people were somewhat daunted by the continuing lack of success in finding an HIV vaccine, typical human perseverance is probably still there, and there are many people trying to find a vaccine. And I'm hopeful that in at least my lifetime we will see a vaccine. It's not beyond the realms of possibility. It just means we need to continue to better understand where the Achilles heels are in this virus. The MRSA bug or bacteria, the methicillin-resistant Staphylococcus aureus organism, is indeed changing, but it's changing from the perspective of its ability to evade antibiotics. So it takes on multiple antibiotic resistance. However, the antibiotic resistance genes that enable this bacteria to avoid antibiotics, and it's a very serious problem because we are running out of antibiotics with which to treat this disease, hence the reason why we'd like to try and generate a vaccine to prevent people from becoming infected with MRSA. Now, those genes that correlate with antibiotic resistance seem to have very little effect on the surface proteins of the bacterium, which are recognized by the immune system. So the challenge for us is to identify those proteins on the surface of the bacteria, which, when the antibodies generated by the immune system bind to the bacterium, can facilitate the removal and the killing of that bacteria from the human being. So the challenge right now, as I say, is to identify those proteins with which we can generate a vaccine to generate a protective immune response, such that people don't become infected with the MRSA, such that they don't need to be treated with antibiotics.